Good morning, everyone. My name is Chandan Ghosh, and welcome to my math channel, Mathematrics. In today's class, we'll be discussing one of the most important topic in the field of mathematics, which is trigonometry. In our class, we'll be covering some of the important trigonometric functions and its practical applications. Hope you will enjoy. Depending on wherever you study, you have heard of trigonometric functions like sine, cos, and tan. People often ask, where did they come from? In today's video, we'll find that answer. And just to show how they have come up about, we'll consider how pi is seen with a circle. So in our last video, we already have showed how pi is come about. Let me take, just to recapitulate that, let me draw one circle. You can try at home as well. And draw the diameter. So this is the circle, there's the diameter. So if you simply divide the circumference by its diameter, you'll always get a number 3.141. It's an approximation. Now, if you simply make bit smaller one and repeat this thing, you'll again get 3.141. If you take even bigger one and repeat this, you will get exactly this one. So isn't it so interesting? Irrespective of the size of the circle, this ratio remains unchanged. And this exactly is pi. And with this pi, we can simply derive the formula of the circumference of a circle. So pi is nothing but circumference by diameter, which implies circumference equals to diameter is nothing but 2 into r, where r is the radius of the circle, so it becomes 2 pi r. Yes. So, along this line, we'll try to, you know, we'll try to show you how this happens if we take a right angle triangle. Let me draw one right angle triangle here. Yes. Uh, you know, this is 90 degree, and I have taken this angle as 45 degree. I have measured this. Let me name them first. So this is the base, this is the perpendicular, and this is the hypotenuse. So I've taken a base of 1 meter. So if it's 1 meter, you can easily calculate how the perpendicular would be. So tell me how it would be. It would be 1 only. Why? Because this is 45 degree. So this becomes 45 degree. So this equals to this. So if this is 1, this is 1, what would be the hypotenuse? Using Pythagoras theorem, so hypotenuse would be square root of p square plus a square, which is nothing but 1 plus 1, which is root 2. So it becomes root 2. Now what we'll be doing here, let's divide this perpendicular side with a hypotenuse. So what we'll do, we'll divide perpendicular side with a hypotenuse. So what the value we are getting here? It is 1 and this is square root of 2. Now I'm just making this right angle triangle bit larger. I'm extending. So let me draw it again. So this I'm taking a bigger right angle triangle. This is 90, keeping this 45 degree. This is base perpendicular. I'm making it as 2. So again, as I showed in the previous example, this will also become, so your hypotenuse would be square root of 4 plus 4, 8. So 2 root 2. Yes, I'm repeating this for this uh, right angle triangle as well. So this ratio becomes P by H becomes, this is 2, 2 by 2, 2. So 1 by root 2. This is 1 by root 2, this is 1 by root 2. Let me take even bigger one. Take a note of this. It was 1 by root 2. I'm taking even bigger one. This is 45 degree. This is right angle. I've taken base as 3 meter. So this also 3 meter. Now your hypotenuse would be square root of 9 plus 9, which is nothing but 3 square root of 2. I'm repeating this for this triangle as well. So P by H, which is becomes, this is 3, 3 by 3 square root of 2, which is 1 by 2. Isn't it interesting? Irrespective of the size of the right angle triangle, this ratio remain unchanged. So this is denoted by sine. So this is 45 degrees, so I can denote sine 45 degree equals to 1 by root 2, which is nothing but perpendicular side by hypotenuse. So make it general. Instead of 45 degree, if we take theta, it becomes sine of theta. Let's say instead of 45 degree, I have taken an angle of theta. And theta, definitely theta lies between 0 to 90 degree. So sine theta becomes your perpendicular side by your hypotenuse. And this ratio will remain unchanged. So sine theta is the perpendicular side divided by the hypotenuse of a right angle triangle. We'll repeat this for, again, just to find what is cos theta. I have taken a note of this. Sine theta equals to P by H. We can repeat this for, again I have taken 45 degree. This is base, this is perpendicular. What I'm doing now, instead of dividing perpendicular side with hypotenuse, I'll divide base with hypotenuse. Let's say I've taken it as 1 meter. So this is 1 meter, this is square root of 2. So base by hypotenuse, this also become, if you repeat, if you perform this for a bigger triangle or even small triangle, this ratio will remain unchanged, and which is denoted as cos 45 degree 1 by root 2. In general term, instead of cos, if you make it is theta, it becomes base by hypotenuse. I will put it over here, cos of theta base by hypotenuse. Now, similarly, we'll find what is tan theta. Tan is basically simply if you divide your perpendicular side by your base, that becomes your tan theta. So tan 45 here becomes 1 by 1. This is 1. From here we can take a note of the tan theta equals to your perpendicular side by base. Just pause. And this is why we teach trigonometric functions to find the missing angle or missing side. So we'll come to that. What's the use of? First of all, you may be asking why we need this trigonometric function. Definitely, we'll find that answer as well. Let me put it this way. Uh, if you have been asked to measure the height of Burj Khalifa, so it's it's very difficult to measure, correct? So how can you do that in a smarter way? Let's say this is Burj Khalifa, yes, and you are standing here, saying this. This is you. So, and this is, let's say, height. This is the height. I need to measure the height of Burj Khalifa. What I've given how far I'm from the base of this, uh, monument. Let's say this is P. This is given. So how can I do that? It's a simple way. If I just look up, I'm connecting this. And which is, let's say, making an angle, let's say theta. This is the height of the man. So let's say this is x. So what is given here? This angle is given. The angle it takes to see the top of this Burj Khalifa. What is given? B is given, the distance from the base to the person, and the angle. So what I need to calculate this, because this is given. How will you do that? So simply, let me just name this as ABC. I need to find AB. So I can simply use tan theta. Let's say tan theta, which is AB by BC. So BC is X, BC is given. So I can find AB equals to BC into tan theta. So if it's, let's say it's a 45 degree, you know the value 45 degree is 1, or any value, let's say tan 30 is given. So you know the value of this, you know BC, this, you can easily calculate AB. If you get this, simply add this, the height of the person, you'll get the height of the Burj Khalifa. So this is one of the example of tan theta, and this is extremely important for you to know what's the application of these trigonometric functions. You can explore more. Yeah, coming to this, sometimes when I ask students, what's the value of cos, let's say cos 0 degree, to simply say it's 1, or cos 90 degree, it's 0. We'll find this answer today. Let me draw one right-angled triangle. So let's say this is theta. A, B, C, let me put it this way. Cos of theta, which is BC by hypotenuse AC. So we need to find the value of cos 0. So this is theta. If I need to make 0, means let me draw this one, just to make it simple. This is, I keep on reducing this angle. Eventually, A will coincide with B. When if theta tends to 0 degree, A will coincide with B. Yes? So for theta equals to 0, A will coincide with B, then that point in time, your AC will become BC. So for cos of 0 degree, we know that it's BC by AC. In case of theta equals to 0, AC becomes BC. So we can put it DC over AC, which is so cos 0 1. Isn't it so simple? Yeah. You can do it for sine 0 as well. You can try at home. Now we will find the answer of cos 90. Let me draw it this way. Cos 90, we're increasing this. So at the end, what it will happen? B will move towards C if I keep increasing theta. And for theta equals to 90, so B will coincide with C. So if B coincides with C, then cos 90 degree equals to, in this particular example, is BC by AC. For 90 degree, B will coincide with C. So BC segment will become 0. So this ratio will become 0 upon AC, which is 0. Simple. I'll find this answer in another way. Let me draw a circle using coordinate geometry. This is x-axis, this is y-axis, this is origin. Let me draw a circle. And this radius is r. And I'm taking a point here on the circumference, which makes an angle theta with x-axis. So this is theta. This is the point A. So what should be the coordinate of A? Simply, this is given. What are the given things over here? The radius. Radius of the circle is given r, angle is given with x-axis theta. I can simply calculate. So the coordinate would be this and this. So what is this value? Simply r cos theta. R of cos theta is the x component and r sine theta is the y component. So this is your r cos theta. This is r sine theta. Yes? Now, if theta tends to 0, so your A reaches over here, then theta becomes 0. If A comes here, your x component becomes this one. So this is also r, and this is nothing but if A comes here, the x component will be exactly r. So r cos of theta becomes r when theta equals to 0 degree. So simply cos of 0 degree equals to 1. Hence true. Now we'll find the answer of cos of 90 degree. So now you keep increasing this theta unless A reaches this point. So if A reaches here, 90 degree, in that case, your y component of the coordinate of A becomes r. So this is also becomes r. So r sine of what it will become 90 degree equals to r, as well as so sine 90 degree, which is 1. At the same time, if this component, your x component, what it will do? It will keep reducing, and for this one, this component will be 0. So your r of cos 0 degree becomes cos 90 degree becomes 0. So as r cannot be 0 for this for this circle, so which implies cos of 90 degree equals to 0. Hope you will find it interesting. Thank you.